All right. Hello, everyone. Let's get started for today. We're going to continue lecturing on Chapter 8. And so today we are in Chapter 8, Section 5. As the label at the top said, this is the chi-squared test. It's the chi-squared test for sigma squared. I just left it at that on the title page, but it is also used for sigma. And just remember, sigma squared represents variance, and sigma, of course, is the population standard deviation. Now, so as you might imagine, since we are using the chi-squared test, right, this is going to be very similar to what we were talking about in the previous chapter, in Chapter 7, Section 4 to be precise, where we were forming confidence intervals for the variance and the standard deviation. And so, like I said, we're going to be considering the chi-squared distribution. So we're just going to review a little bit about the chi-squared distribution. It is similar to the T distribution in the sense that it is a whole family of curves based on degrees of freedom. So if we have a different sample size, then we are going to be using a different graph, essentially a different size and shaped graph for our chi-squared distribution. Now, it is skewed to the right. Okay, that's one of the facts about it. You can see the tail to the right side is elongated. Also, when we look up our critical values, all of those are giving us right-sided areas. And so we will be finding here, this is going to be chi-squared alpha divided by 2 on this side. And if we need to make it a two-tailed test, we'll look at this left area, right? The left area is going to be our critical region. However, the table gives us values for right area. So everything to the right side of this chi-squared value, what is this one? Well, that area would be everything except alpha divided by 2. That would be 1 minus alpha divided by 2. So essentially what we're going to be doing is let's just go in right now and practice finding critical chi-squared values for various degrees of freedom and various types of hypothesis tests. So let's explore a few examples just utilizing, I believe it is table G in the book, the chi-squared distribution table. So let's begin with Chapter 8, Section 5. We'll do example 21. That's the first example in this section. And here it says to find the critical chi-squared value. Okay, so chi-squared value. Let's just say, for the moment, it's critical. That's all we know. I don't know what that is. I'm not even going to write at this point alpha divided by 2 or 1 minus alpha divided by 2. Because I haven't thought it that far ahead, and I'm not sure which region I'm looking at. So this is what I'm looking for. All right. We are told the degrees of freedom. They don't give us the sample size. They just tell us there's 15 degrees of freedom. And then we know alpha, the alpha level, the significance level for the test is going to be the standard value, 0.05. And the test is right-tailed. Okay. So whenever I'm looking at, well, finding any kind of critical region or any kind of critical value, I'm always going to create a little sketch of the distribution. In this case, the area underneath the curve that I'm shading is on the right side, and this area is going to be 0.05. Right? Now, this right here is the critical chi-squared value that we're searching for. And that's what we'll look up in the table. Okay, so the first thing that I'll mention is that since we're looking at a right side area, we can just call this one right here, we can call this chi-squared subscript alpha. And here alpha is equal to 0.05. 0.05. So since this is a right-tailed test, the area is on the right side, so that area is just exactly alpha itself. What we'll do is we'll be looking in the row corresponding to 15 degrees of freedom, and then we'll look at the column. Alpha will be in the 0.05 column. And so we'll go all the way down, and the value that we find there, I believe, I just looked it up a second ago, it was 24, 20, hang on one second. Sorry, malfunctioning touch screen for a minute. 24.996, that is the cutoff for our critical chi-squared value that defines the rejection region for this right-tailed hypothesis test. Okay, let's move on real quick to the next example. This is 8-22, it's got to be, on page 462. It says here we're going to find the critical chi-squared value for 10 degrees of freedom. All right, so df equals 10. All right, and alpha is equal to 0.05. And here the test is going to be left-tailed, right? So watch closely. That right there is how I spell left-tailed. Haha. Okay, and oh, that's a terrible sketch, but oh well, whatever. Here's 0 right here. All chi-squared variable values are positive, and so here this truly is the y-axis right here. Now we're trying to find. Let's sketch it in orange here. We're trying to find this particular chi-squared value, so that the area to the left is exactly alpha equals, what was it, 0.05. That shaded in orange region there is 0.05. So what do I put here, and how do I look this value up? Well, keep in mind that if the left-hand area, the area to the left side of that vertical line underneath the curve, if that is 0.05, then on the right side, that's going to be 0.95. And so here, this is going to be 1 minus whatever alpha was, right? It doesn't matter if we know what the Greek symbols are called or what the proper algebraic notation is. Who cares about that? We need the value to use. There it is, 0.95. That's the value that we're going to use. So we're going to go to our table. So we go to Table G in the back of the book on page 782. And we look in row 10, okay, so that's our degrees of freedom, 10 degrees of freedom, so we'll find where the proper row for that. And we will be looking in column 0.95, right? So it's going to have 0.95 for alpha at the top, and we look up the critical values, 3.940. All right, one more quick one. Okay, and so this last example is on how to find critical values for a two-tailed hypothesis test. And so that's what I have jotted down here, example 8-23, all right? I guess it starts out on the same page, on page 462. And here they're telling us find the critical chi-squared values for 22 degrees of freedom, when alpha equals 0.05, and it is a two-tailed hypothesis test. That's how I spell that. Two arrows going to both directions. Okay, so what's the procedure for this? Well, first of all, let's get a quick sketch of what it is that we're looking at. All right, so remember, whenever I sketch my distribution curve, I usually like to remind myself what the degrees of freedom are. So 22 degrees of freedom for that one. And we're going to be finding these critical chi-squared values. All right, so alpha, we said, was 0.05, and that means that the area that we have on this side, on the right, is going to be 0.025, and the area over here to the left of the leftmost critical chi-squared value is going to be also 2.5%. Because it's a two-tailed test, we have to divide alpha in half, and each one of these two tails on either side is going to have exactly half of the alpha area. So here, this one we generally denote as alpha, and this is 1 minus alpha. Okay, that's for a single-tailed test. That would be for a right-tailed test, and this would be for a left-tailed test. Since we have to divide up alpha by 2, then this first one on the right is whatever alpha is divided by 2, and that's the area underneath the curve and to the right of that chi-squared value. And similarly here, we're talking about a right area, and so that's why we have 1 minus alpha divided by 2. Let's go ahead and write down what these are specifically. So that would be chi-squared 0.025, and over here we would replace 1 minus alpha over 2 with 0.975. Okay, so scroll on down, and now we'll do the same exact thing. We'll use row 22 for 22 degrees of freedom. For, let's say for this value, chi-squared subscript 0.975, that one we look up and we find is 10.982. For our second one, we'll look up, okay, the same procedure. We'll go to row 22, and then we'll use the 0.025 column, and we'll find this critical chi-squared value is 36.781. And so that gives us our method of finding our critical values that define our critical regions. And then the hypothesis test is going to go the exact same way. We're going to do the exact same 5 steps that we do for the traditional method. Or if we're using the p-value method, we're going to basically do the exact same procedure. And it's going to look similar to how we had to work with the p-value method when we were doing the t-test using the t-distribution. Because, well, those are similar to one another because of the degrees of freedom. All right, we'll conclude now and get into the hypothesis testing side of 8.5 in the next video. Stay tuned.